Hello, 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 dear developers. Welcome to the next episode of From SIA Meetup. We are live, we are on air, and we have really great speaker and great topic for today, for tonight. Let me first briefly introduce myself. Just to remind that Maxim Salnikov is with you. I'm one of the organizers of From SIA Meetup, and we are always looking for the speakers. If you wish to deliver a session about frontend in a very broad definition, let me explain you what to do. We have a special call for papers form, super simple form. Just send your proposal, and I'll be happy to see you on this virtual stage. I will send this link to the comments feed a bit later when our dear speaker will start their session. And also please to stay updated, follow From SIA Twitter. I try to announce events like this in advance, and let's stay connected there. Let me introduce our today's speaker. Let me add him to the stream. Hello, Praveen.
Hey, Maxim.
Thanks for joining us. It's a great pleasure to have you, and I'm really looking forward to hear about GraphQL, about what you folks do in Hasura. And let's make this session interactive like we always do. And right after the session, which will take maybe around 45 minutes, we'll be happy to answer your questions. So just, dear attendees, send your questions via YouTube live comments. I will read them, and let's have a discussion after the session itself. Now, without any further delay, Praveen, the stage is yours. Let me add your screen, and good luck. Please tell us about your experience with GraphQL.
Thanks, Maxim. Glad to be here. So today I'm going to talk about GraphQL and how it fits in the whole front-end, back-end ecosystem, how front-end developers and back-end developers interact with GraphQL, and how you can onboard if you're new to GraphQL and stuff, right? A little bit of introduction about me. I'm Praveen. I work as a developer advocate at Hasura. Full stack. So I've been working with React and like Node.js, like a mostly JavaScript stack, and Python and a little bit of other nitty-gritty stuff, right? So, and obviously powered by Stack Overflow for most of the stuff around CSS, right? And so I transitioned from like a jQuery to React. So it's been like a few years that I've been in this space. So that's like a pretty good evolving of the front end stack that I've seen through, and also on the back end, more from like an MVC architecture, like a Django to like a Node.js stack, right? So and obviously like packaging, also the Docker, which made a lot of things easier for developers, right? So so this introduction, the stack that I mentioned was actually to ensure that how things have remained the same on the API side. When I moved from Django to Node.js, the API layer was still REST APIs, right? So that was still fundamentally, it was backing the whole front end and the back end stack. And came in GraphQL. GraphQL obviously came in 2015. Facebook introduced it for like a mobile-friendly spec to fetch lesser data. And the whole idea was to like build mission-critical apps pretty fast, right? So and how GraphQL helped that is by by providing data access pretty easily for developers. So the bottleneck for organizations is to expose data through APIs, expose data in different sources like databases, your internal data source, your external SaaS services into like an API which people can access pretty quickly, your clients can access pretty quickly, right? So GraphQL tried to solve that by being a unified layer, and it also solved a big problem of like a self-serve API, because with REST APIs, what used to typically happen is there's a dependence of the front-end developer on the back-end developer, primarily because of the way the API is developed. It's a static spec, right? So you develop like a post endpoint. It has a specific body, and if something has to be changed, you have to obviously go back to the backend developer and say that I need this changed. So there was a friction involved in adopting the whole API stack, right? And GraphQL tried to change that by being self-serving and self-documenting and more flexible around providing a wide range of data access and letting the client or the front-end developer choose what they want, right? And as I said before, like the wide range of data, it typically means that the shape of data can be different for different queries. And like you can have nested data in all in one query. And with REST API, obviously you can still have it, but for the same use case, your data could be different on a desktop versus a mobile interface, right? So in a mobile app, you would probably want to fetch lesser data, which is why Facebook actually introduced GraphQL in the first place. And in a desktop, obviously, the data fetching would be slightly larger. Now, for this, you'll probably need 2 REST endpoints, or probably you are fetching more data on your mobile app using the same REST endpoint that was used on your desktop, right? So different shapes of data and getting lesser data for different use cases was a big solution that GraphQL provided, right? And because you can do nested querying and stuff, access to multiple data sources was actually pretty easy on the front end side. Typically, you see the documentation is the types and schema of the GraphQL schema that you have, and you probably don't need to know which data source this particular schema is coming from. But underlying backend is obviously making it easy for you to actually fetch data from multiple sources. And all of this is happening through like a single API endpoint, because GraphQL comes with like a single endpoint, and the developers don't need to worry about like configuring and changing endpoints and deprecating those and stuff, right? So that's also there. And the whole user experience around using GraphQL. So GraphQL, I would say that it's pretty good for front-end developers, because primarily what the experience is that you have like a GraphQL interface, and GraphQL comes with like a schema and a type system, right? So what that allows you to do is to build interfaces on top of those spec of a well-defined schema and a type. You can now build interfaces which can improve the user experience a lot better, right? So you have GraphQL, you have GraphQL Playground, all of these UI tools which lets you query and get data, test your APIs pretty quickly, and also like see the types and like read documentation pretty quickly on the fly, right? For any GraphQL endpoint. This is obviously possible with REST API through Swagger spec and Open API and whatnot, but there was no consistency involved in any of the REST APIs, right? So you never know if a particular REST API has the spec defined for you to look at, right? So the consistency that GraphQL provides is the schema and type system, and through that you have this whole introspection that's available, which lets you build good tooling around it, and that improves the user experience a lot, right? So the GraphQL was a big change in the way APIs were built. So the tech stack that I mentioned previously, a lot of things changed. Like React became a big thing. JavaScript, Node.js backends became a big thing, but the underlying REST API did not change too much early on. But now we're starting to see people adopting GraphQL and the benefits and the user experience that it brings to all the developers, right? So that was a change, and I've also adopted to that change, and it's been a good journey with GraphQL so far. So I want to share some of the experiences and how Hasura has adopted the whole GraphQL space, right? So now you might be wondering, like, why GraphQL? And if you look at the consumers of today's application development, you have like mobile apps, web apps, microservices, APIs, SaaS services, vendors, and stuff, right? So, but compute is getting easier. You have serverless function, you have unlimited resources that you can point to. So infra is not like a huge bottleneck anymore. And writing business logic with serverless functions is pretty easy right now. So you like write very limited amount of code, and then you isolate that into like a function, and then you deploy it, which is having infinite compute. So that workflow is becoming better. Obviously, there are some minor issues around the whole serverless ecosystem, but the ecosystem is getting better, and the whole consumers of these, like the mobile apps and the web apps, are able to now hide the complexity of querying data through multiple API sources, right? So the data access layer, which is the middle one that we're going to talk about, that takes a lot of time to like build and iterate on. And why? Because if you look at the consumers on the right, there are different types of consumers. You have mobile apps, which might require lesser data, web apps, which might have higher data requirement. The shape of the data might be different, and microservices and APIs will have different, like well-defined, structured data, right? So SaaS services will have their own spec, and they've already written their API, and you might want to integrate them for your client, right? So data access, when combining with all of these different consumers, it will take a lot of time to build and iterate, right? So building one endpoint for mobile app, one endpoint for web app, for your IoT app, all of this is going to be a lot of work and maintenance and deprecation and versioning and stuff, right? So that's a data access is generally like a problem that needs to be solved for application development. And on the left, if you see the producers who are producing data for you, like the databases typically do that, and you have internal services for your authentication, maybe your file system, which has data that's stored separately, and you also have the external services, the SaaS services and the vendors like Salesforce, Stripe for payments, Algolia for search, and so on, right? So they having the data, they store the data, they produce the data, and you need a way to bridge this this data that's being produced to make it as easy as possible for your consumers to be able to like quickly query and fetch data from a middleware that's the data access layer, right? So your mobile app typically cannot really talk to the database directly. You need an API layer to talk to that database. And we typically want that API layer to be secure with authentication and authorization and stuff. And all of these consumers, despite being different with the amount of data that they are fetching, the authorization, authentication, everything would probably be the same, irrespective of the type of the app that you have. So there's a common layer involved, and this data access layer is key to actually build solid apps pretty quickly, because databases are getting better. You have all of these cloud providers giving you pretty solid, scalable database solutions. hosted solutions for you. And SaaS services are also being adopted incrementally. Like you have Stripe for payments, as I said before, and Algolia for search, and so on, right? So there's a lot of external services in Zapier for all of these integrations that you have. So they're all getting better. So this data access layer is now the one that needs to bridge in, and 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 this is where I feel that GraphQL is that data access layer, which will make it all of this easy to get data from multiple sources, which is pretty easy with GraphQL. I mean, not easy, but it's actually like streamlined to be better. Easy is not the right word, but it's going to be making it streamlined to make it a structure around it. You have a schema and a type system around it, so everything's like more maintainable over there, and more consistent over there. And the consumers, it's the easiest, where you have a self-documenting API for all of these web apps and mobile apps. The front-end developers will have quick access to the GraphQL schema through the introspection layer, right? So GraphQL becomes a data access layer, and that's why GraphQL becomes important, and you need to adopt GraphQL going forward with services that you're building. So is it like a comparison between GraphQL versus REST? No. It's typically a combination of both GraphQL and REST, because I mean, let's be honest here, the REST APIs are here to stay. A lot of organizations have built a lot of APIs over the years, with a lot of tooling around it, and it's been pretty solid. There's nothing really fundamentally, hugely broken system that's had to fix. GraphQL improves a lot of things over REST API, but it doesn't necessarily need to replace REST APIs in all use cases, right? Obviously, if you're building an app from scratch, maybe GraphQL is a good choice. But if you already have an existing system with REST APIs involved, and a lot of tooling built around REST APIs, monitoring your analytics and whatnot, then you probably don't need to like completely rewrite them to GraphQL, because then there is a cost analysis that you need to do, the benefits that it brings you and whatnot, right? So in that case, what will typically happen is you have a GraphQL layer on top of your REST API. In use cases where you want to make data access easier for developers, because adding a GraphQL layer means your developers will have this documentation, the introspection, and all of the other benefits that GraphQL brings in. And underneath, what is happening is your GraphQL server is actually making a query to your REST API, and with all the authorization, authentication, and everything involved in between as well. So it's more like a proxy to your existing REST API. And the complexity is hidden for the clients, because now it's just a one endpoint that the client needs to worry about, and all of the introspection features, benefits, everything is availed by them. But underneath, the backend developer ensures that this is just proxying to the REST API, and all of the REST API tooling will continue to work, and the monitoring and stuff can continue to work, and hence it's not about GraphQL versus REST. It's about using them both together because of the existing tooling that's there, right? Next up would be around the challenges in adopting GraphQL. So developers, right? For developers, the challenges are around performance, caching, and stuff. So for performance, for REST APIs, you typically have like a get endpoint, which you can do like caching. You can cache a get endpoint and then not worry about. So you can put a configuration on the CDN or an Nginx conf, which can like do some caching for you, like basic caching for you. That will solve a lot of problems for you on the caching side, because you have an endpoint which is unique for a particular data fetching use case. With GraphQL, the problem is that there's only one endpoint, which is a post endpoint. So the request body is what will change every time you make a query. So there's no way to cache a post request, which will keep changing. So there's a fundamental issue here with how you can do server-side caching for GraphQL. And on the performance side, what will typically happen is when you're writing resolvers with GraphQL, typically, um, you have this n+1 problem of data fetching, where let's say you're fetching authors and articles. For each author, you're fetching the articles that they've written. It becomes like an n+1 kind of a loop, uh, uh, which will make your queries slower. The response will be pretty slow. So there are obviously ways to tackle that, but that's a typical problem being faced. You can use data loaders, batching of queries and stuff, but it's still a problem that needs to be looked at when you're writing your resolvers on your own. But obviously, there are tools in the market which have now become like compilers. So when you write a GraphQL query, they compile to like a SQL statement for your database access. Obviously, it doesn't work for all use cases. Like you cannot query your external service through like a compiler. But for example, if you have like a GraphQL query which needs to map to like a database, you have all of these tooling ready, which can be like a good performant compiler for you, right? So there are solutions for the performance problem, but still it's something that needs to be noted by developers when they start the GraphQL journey on the back end, right? So then next up is authorization. It's kind of a challenge as well as something that GraphQL makes slightly easy because of the schema and the type system. So once you have a schema, you know that these are the fields which doesn't need to be allowed for access for a particular user type. So the patterns can be set up more easily than a REST API because of this whole schema system. But obviously, the reality in actually implementing them on the code, the existing tooling that's available, there's GraphQL Shield if you're writing a resolver, and so on. But there is a limited set of authorization setup that you can have, right? And also, the amount of code that you need to write for all of these is going to be pretty huge for authorization, right? And on the operation side, GraphQL, because of a single endpoint, it becomes like a single point of failure. Single point of failure is actually like a huge problem for certain applications. With REST APIs, at least if let's say one endpoint is down and the other endpoint is up, at least partially your application is working. And with the right set of monitoring, you can bring back the other endpoints up. But this one is like your whole application's API is down, so it's a problem that needs to be solved. And rate limiting. Previously, with REST endpoints, you can rate limit based on a particular URL. So if somebody is spamming your user endpoint /v1/users/get or whatever, that endpoint, you can actually limit the number of requests that can be sent to that particular endpoint, and then allow other requests to still go through normally for other endpoints, right? Also, it can be IP based and what. With GraphQL, again, now going back to the whole single endpoint, one post request body, you cannot rate limit that endpoint. That endpoint is your primary endpoint. So globally, you cannot rate limit a particular endpoint, which will be counterintuitive for your users. And so the way rate limiting will be thought about is through your post request body, how your query is being made. So you need to parse the query and then limit the request. But obviously you can do IP based, very similar to how you do REST APIs. But if you want to do request based rate limiting, you need to go into the request body and then do the rate limiting, right? So that's something that you need to worry about when you're adopting GraphQL. And on the business side of thing, like what's the cost involved in adopting GraphQL, right? So if you're new to GraphQL, building GraphQL servers is pretty hard. Obviously, all of the challenges that I've mentioned above are primarily applicable for backend. The front end side of things actually becomes a lot easier. In fact, it solves a lot of problems that previously you had. So the cost is primarily reducing on the front end side, and then it's increasing on the back end side because of the complexity that's involved in building like a GraphQL server. Right. So that's something that you need to look at, the trade-offs that you need to look at when you're adopting GraphQL, and there's challenges that needs to be looked at before going over, right? So here now I want to introduce like Hasura 2.0, where some of the problems have been solved for GraphQL, the ones that I've mentioned in the previous slide. What has changed from Hasura 1.0 to 2.0? So Hasura is basically like your GraphQL API interface, like an API interface, or more like a data access layer for your data sources. So what that means is, let's say you have like a Postgres database, you have a MySQL, you have like a SQL Server or any kind of database. You want APIs, you want API access to those databases, and you want to be able to query that from your front end. Let's say you have a React app or your Vue app, and then the Vue app you want to actually query to your database. You have like a users table that you want to query. Now, obviously, if you are writing your own server, you will write resolvers and stuff, which will make the query to the users table and whatnot. But now let's make this a little complicated, where you actually fetch users and the products that they've ordered in an e-commerce app. Now you need to write a query which will actually join data between users and products table on the orders table, and then see and make it optimized enough to not have the n+1 problem, and also make an optimized SQL query that actually fetches data pretty quick. So Hasura tries to solve that problem by being a compiler. So whatever the GraphQL query that you given is compiled to a SQL query, which is the most efficient possible way for any kind of nested query, and then you get like a JSON response back from Hasura to your client. So that's like a compiler-based approach, which is pretty performant for fetching data from the data sources like databases, Postgres, SQL Server, MySQL, BigQuery, MongoDB, and so on, right? So all these databases, data fetching will be like in a compiler-based approach. A lot of tooling available in this space, like PostgreSQL works for Postgres. There is GraphQL SQL compiler, I believe, which also works for other SQL databases. There's a lot of tooling around this, which acts as a compiler and actually gives you APIs. In fact, Postgres was the one which is available for REST APIs, which actually gives you REST API on top of Postgres, right? So there are a lot of tooling which exists, which acts like a compiler for giving you API access. And Hasura now connects to multiple databases and multiple data sources in a single application, and makes it easy for data access, right? So, and Hasura also gives you an option to create REST APIs on top of GraphQL. So let's say you have a GraphQL API. So once you connect Hasura to a data source, you get a GraphQL API. Now you can also create a REST API on top of that. This is a very specific use case which large organizations might have for legacy tooling. But still, this is an option that you still have it available, right? Typically, GraphQL is like a layer on top of REST APIs, but in this particular use case, a REST API has been created on top of GraphQL, which can be used for a specific use case. And generalized authorization, right? So you have the database layer which you need to access, and you also have your custom business logic, and you have the external third-party services which are probably written in GraphQL. Now you have your application, which is like a user who wants to access data across these sources, but you need to now restrict access to these data sources granularly, saying that this particular user has a limited permission to access the data in the tables. This user has access to the external services, which can be accessed pretty easily, right? So this authorization layer now can be generically defined, declaratively defined in the Hasura layer, and you don't need to write any code for this, right? So the authorization layer becomes now no code and declarative and configurable kind of a solution. And if you want to write your own code for authorization in your own GraphQL server, that's going to be a lot of code written and a lot of maintenance that's required for authorization layer, right? So, so this is different from authentication. So authentication is when you actually sign up, sign in, and do the token verification or the session verification, right? So that's different. That you can bring in whatever solution that you already have been using. Uh, that doesn't change. You can integrate with JWT, or you can integrate with any SaaS services that you already have been using. Authorization is when things become a little more difficult, where you have like a role-based permission that you need to restrict access to, and Hasura makes a lot of things easier for you by making it declarative and across multiple sources. And we also have generalized joins coming soon. So what this means is that you can now join data between multiple sources. So if you have data in Postgres and you have data in MySQL, and you have like a user table in Postgres, and you have, let's say, orders in MySQL for some reason, like let's say analytics or maybe data fetching is faster in some tables, in some databases, and so on. So you're having data distributed in multiple sources. And obviously, large organizations will have this use case of having different databases and different teams working isolated on different projects, and they have different databases set up. But there are probably common data sets that needs to be joined together. And what we're going to do is we're going to join data between two different tables in two different databases. And GraphQL makes this all easy, because now you're making a query to a single endpoint. So you make a query, and then you get data from multiple sources at the same time in a single query, right? So that's something that's coming soon. We already have data remote joins between your custom GraphQL server to your database, but then now this makes it very easy when you have your custom servers written, you have databases, and you want to join data between all of these different sources dynamically, right? So how does Hasura fit in your stack? So previously you have like developers like communicating with like a monolith, like an MVC architecture. You have services written, and your monolith gives back your response to the client. With Hasura, what happens is the developers make a GraphQL query. So the GraphQL is the interface through which you actually communicate with Hasura, and then Hasura actually parses the GraphQL query, adds the authorization layer, checks all sorts of sanity checks are done. Then it makes a query to the database or the SaaS services or your microservices, depending on the query that you've sent, and then gets back the response from them, and then gives it back to the client. So your client actually directly contacts the Hasura GraphQL endpoint, and then that's it. Then you get back the response from different sources combined, and Hasura takes care of that by being a compiler for databases and by being like a join for different sources of data, right? So and you also have like asynchronous logic, where you have stateless business logic written in serverless functions. So let's say you want to like send an email after registering a user. Sending an email doesn't need to be a blocking action on the front end. So you can like trigger a register user endpoint, like a mutation, and as soon as the user mutation happens, you can set up an asynchronous action in the background, which is going to be sending an email, right? So it's more like an event driven setup. You set up events on database event on database changes, and then you actually make like events execute for serverless functions, and then perform some actions like sending an email or do whatever action that you require to do, right? So it's like a command query CQRS style interface that we have here. And the databases typically that we support is Postgres, which acts as like Hasura metadata as well, and SQL Server. MySQL is in alpha. BigQuery is also in alpha, which is given by Google. And coming soon would be Oracle, MongoDB, and so on. So basically, fundamentally, we want to try cover most of the major databases being used by people, and you will be able to now join data between all of these sources and so on. And on the front end, so what are the challenges are on the front end? Now that you have seen what the backend looks like and how Hasura can fit in a stack and so on. So client tooling is the first thing that people talk about when it comes to front end. I've said that front end developers, GraphQL makes it easy for all of these front end developers by being self-documenting and stuff, but there are obviously smaller challenges as well, because now you need to decide if GraphQL is your state for your entire app, or you want to use like a different state management app, state management library, and use your GraphQL client as just pure data fetching library, right? So there are like tools, there are client tooling like Apollo, Urkel, Now people are using React Query as well for making GraphQL queries and act as a client. So the client's job is to actually make it easy to make this GraphQL query, which is the weird little syntax, which is, I mean, technically you can make a fetch API call to your GraphQL endpoint by using a request body, which will have the escaped GraphQL query. But what these GraphQL clients do is make that process a little easier. You define one client which will make queries on behalf of you, because you don't need to define the fetch endpoint, every fetch library every time, because it's the single endpoint, the single structure. It's a post endpoint. The structure is the same. Headers, you send in whatever session information. So everything is same. So you configure it once, and then use that across all of your uh, components and pages and whatnot, right? So um, the interesting bit here is these tools also give you caching on the front end, which means the amount of data that's fetched when you're changing components is going to be pretty less because the data is cached. So if data hasn't changed, it will be it will not make another query to your backend. You can obviously trigger a forced query, but typically the number of requests being sent to your server will be less with caching on the front end. But now the decision making would be around will the clients now can replace your existing state management tools depending on how large your application is. If your app is like hundreds of components, then you might be thinking, okay, let's separate state from data fetching, and probably use like a simple client, right? So and still, obviously, you can still use a fetch API to just make GraphQL queries, get a response, and then be done with it. But clients also make GraphQL subscriptions a lot easier because, like with the amount of API layer that they expose, if you had to write your own subscription layer, you have to probably define a WebSocket connection, which is going to be a lot of pain generally, both for backend and frontend. These client toolings actually make this a lot easier, right? So that's the underlying benefit. So there's a trade-off in what kind of client you use, and depends totally on the use case that you have, right? So there's also like another category of tooling on the front end, which is the Fluent GraphQL clients, which lets you write GraphQL queries as objects. So typically you write your GraphQL query as query, then followed by your author, ID, name, whatever, right? So what these clients let you do is do author dot get of ID dot get dot var clause, sort by, order by, whatever, right? So you can do like this object based chaining based queries, which is similar to like how you do ORM setup on your backend for fetching data from a database. This query structure makes it a little easier sometimes, depending on the use case, obviously. And there are Fluent GraphQL clients, which, like for example, GQLS is something which is a Fluent GraphQL client, which lets you do this, and removes a lot of complexity that other full-fledged GraphQL clients have, and makes it easier for you to write queries as well. But obviously, they have challenges like they probably might not support subscriptions and so on, right? So there's a trade-off, obviously, involved. And if you're not building a real-time app, probably you don't need a subscription layer. So that's another trade-off that you can look at. And generally, the challenges, again, as I mentioned, it's just the whole state management and how you do caching and how do you handle errors. So when it comes to errors with REST APIs, you have the option of handling errors based on status codes. Like if you get a response back as 200, it's a successful request. If it's a 400, it's a bad request. A 500, 502, whatever is a server error, some gateway error, and so on. So you know that these status codes imply something, and you can write code on your front end pretty easily and then handle things, right? That's what you've typically been doing all along. With GraphQL, the problem is that every response has to be a 200, irrespective of whether it's an error or not. And if it's an error, you get that data in the JSON body of the response. So you need to look out for the errors key in your response and then handle the code that the server returns in the errors object and then display a right error message and so on. So there's a little bit of more tweaking involved in the way errors are being handled. And I believe that's something that some of the tooling cannot handle. The tooling, by tooling I meant for REST APIs, you can handle it with some status code tooling, but obviously this is not going to work out for this. And every time you get a response, you need to look at the errors code as well. And there's also like a partial response that GraphQL servers are allowed to do, which is like send data as well as errors in the same request. So some part of your query is actually working, and some part of your query is actually in error state, which means you need to now handle the data that you've received and show it on the front end maybe, and then the error portion is something which needs to be handled separately as well. So that's a huge challenge, right? So um, let's now move on to the backend demo quickly. It would be, hope it should be pretty quick. So this would be on cloud.hasura.io. You can sign up for a new account. It's free, no credit card required and stuff. Let me create a new project quickly on the free tier on the US West region. And let's say Famshia. And I've created this project. Now it's initializing on this endpoint. So this is the GraphQL endpoint that we have. And it's initializing. So once it's initialized, what we'll get is like an access to a console UI, like a front-end UI that you can access. So I stream here from Bangalore, and I've set a region which is on the US West, and there's obviously a ping delay that's happening. So what we've done is we've created a project on this endpoint on this region. This is a free endpoint, and obviously you have like a Hasura Cloud IP, which you can now let your databases expose only for this particular IP and so on, right? So that's something that you can look at once you have the database connectivity option coming up, right? So now we have the interface come. Let me dismiss this. Right, so we have this interface ready. We have a GraphQL interface, which is what I want to talk about. So let's create a data source, which is like a free Heroku database to get started. So I'm going to create like a Postgres database on Heroku free tier, and then use that to create some tables, and then quickly do like a GraphQL demo to fetch data. So we've already like installed Postgres. It's now connecting to Hasura, and we have a data source added now. So we can see that there's a public schema that's ready from the Postgres database. So let's create like a table called users and typically name, and there is an ID, right? Let me quickly add this table. And we have the users table created now. So let's insert some data. Let's say Maxim. And now let's query this data by users, ID, and name. What we've got is like a GraphQL API already pre-generated for the tables that you created. So this could be from an existing database as well. Like you can have an existing Postgres database and then point that to Hasura, then everything should still work if you track the right tables. So this is the users table. We've got the data, and now let's try to insert some user as well with an object. The ID can be auto-generated, so let's do that. Let me insert my user, and let's get back the ID from the mutation. So now we have inserted a user using the mutation. Let's go back to the user's query and then see if the second data is coming up. And there you go. Right. So now again, we can now make this query into a subscription, and this will now be a real-time query. So if there's a change in the data, this will reflect that change immediately. Right. So let's actually also test that. Let's get some other user's name. If somebody wants to comment on in chat, we can quickly add them as well. Okay, I would just say user 3 for now, and we can edit it if you have a new comment coming in. And we can see that the user 3 is now available here. The query is still running, the subscription is running, and hence we can see that the user 3 is working. Awesome. So what Hasura has done for you is basically created like a GraphQL API instantly with queries, mutations, and subscriptions for the database that you just created. This can now be also configured to have like the authorization layer, which will have role-based permissions and so on, right? So let's quickly test this out as well by doing a select with, let's say, custom check, which would say ID equals access user ID and then access to ID and name. So if we have a role called user, so let's test this out. We can remove the admin secret, access role user, user ID 1, and enable back the admin secret. Let's make a query, users ID and name. Let's remove this, errors. Right, so now if you look at the query with the headers, we have the accessories already configured as 1. This will typically come in from a JWT token. So this is just hard coded for now for the demo, but typically this will come in from a JWT token authorization header where you will have these claims written, right? In that case, so what's happening here is I have defined ID as 1. Now you're getting back only data for the ID 1. So this is more like an authorization layer where this user is now allowed to access only their own data. So if I am a user 2, I'll be able to access only my own data, right? So this is to ensure rules are being configured declaratively, and then you're restricting data access for the user, right? So that's the demo that I wanted to show. There's also like on the remote schemas, you can add your own custom GraphQL server that you've written and then join the data with Hasura. With actions, what you can do is you can connect your existing REST API by defining like GraphQL types. So you can write your own mutation or query, write your own type definitions, and then point it to like your existing REST API, and then handle your post request body according to the types that you have, and then you're set to go. Your REST API will now act as your GraphQL API by defining an action, right? So that's actions for you. And finally, on the event side, when I mentioned asynchronous events, like when you're registering a user, you want to send an email and so on. That's event triggers. So when an insert happens on a particular table, you can call a webhook URL, which could be typically a serverless function, but it could be any URL, which is a post endpoint, right? So that's events that you can configure for the tables that you create and for the different data sources that you have. And with Hasura Cloud, you can also have monitoring of all of your APIs. So with GraphQL, that's the typical problem where you have where it's difficult to like configure rate limiting and stuff. But with Hasura Cloud, you will be able to do that pretty easily, right? So this will give you like a stats analytics or metrics of how many queries you've made, what's the execution time, and what the error rate and whatnot. And you can configure API limits and allow list and so on, right? So this is typically like your, depending on how production ready your app is, you can use these features as well, right? So yeah, that's I think fundamentally what I wanted to share in this demo. Going back to my slides, the final resources. So we have something called hasura.io/learn, which is open source, and it's a bunch of tutorials that you can look at for learning GraphQL. There's an introduction to GraphQL course for all beginners, and with all the core concepts being covered for GraphQL. And then there's a front-end series as well, which lets you learn GraphQL with Vue, React, and all these front-end frameworks of your choice, with Apollo client integration as a sample. And there's also Hasura tutorials for you to check out quickly to learn Hasura basics. Right, so this is Hasura Learn for you. All of these are on GitHub. So this would be the repo that I'm talking about. This is the repo. It's all open source. You can even contribute tutorials around this, but this is open source code. So the actual app code is also available for you to check out. There's an app final folder with the working sample app with all the GraphQL integration and stuff. And typically app boilerplate will have the app without the GraphQL integration. So you follow the tutorial, and then step by step we actually integrate GraphQL stuff, right? So it's really pretty interesting, pretty challenging for beginners to learn GraphQL, right? So yeah, that's mostly it from my side. Open for questions. Happy to answer any queries that users will have on Google Meetup.
Thank you very much, Praveen, for sharing your GraphQL story and for demoing awesome product you built in Hasura. Question from my side. So you built tooling for GraphQL that, and I have no doubt that you folks in Hasura are GraphQL experts yourself, and your product for GraphQL is based on GraphQL. So I wonder, how is your development team structured? Are there mainly full stack developers or folks who specialize on like front end, or maybe like exclusively on GraphQL part and then on backend part? So I think it's very interesting for our attendees to know how this works, let's say, in production in large companies, or like what is the size of the company? Maybe this will be the first question then.
You mean size of the Hasura as a company?
Yes, yeah. How many developers build this product, and then how?
Right. So yeah. So I think the core product. So this was launched in 2017, and we did a soft launch on HN in 2018. And back then, I think we were like a 20 developer team across multiple like front end, back end, and stuff. And the server, which is the core of our product, is built around Haskell. And so the server engineering team is primarily around people who build Haskell products, right? So so that's the fundamentals of the product. We have like a Hasura console that you already saw in the demo, which will be the front end team, and that's built on React, and in fact the whole thing is open source. So I'll just open the GraphQL Engine repo. So this repo is the fundamental open source repo of the product. The cloud is the only difference on the cloud is basically you have the monitoring, which is in addition to what you have, and cloud also hosts your GraphQL API on top of that. You can self-host your API using the open source version through Docker. But yeah, we have like a CLI and which lets you do migrations, and that's written in Go. So we have like a few Golang developers who made the CLI, and the community also like contributes as well. And the console is purely written on React and TypeScript. So we recently moved to TypeScript last year. So that's a change that we've done. And on the server side, it's purely Haskell and yeah, so that's the so if you, I mean, this will give you a fair idea of what's the code base looking like. Like Haskell takes 35% of the repo, and JavaScript is 21%. So yeah, so that's the fundamental bits of this. Yeah, now we are probably a larger team because of the whole cloud product and stuff. But fundamentally, this was built early. The early product was built by just 20 people.
Yeah, awesome. Yeah, this is, I think this is a very interesting technical stack, and maybe it could be a reference for our dear attendees, so they know that this product is built on that technologies. Yeah, I don't see other questions in our chat window. That means that we can wrap event up, and thank you very much again for joining us. Let's stay connected, and please keep us posted about your progress on the product you built. And yeah, we'll be happy to see you again on from CI Meetup.
Awesome. Yeah. Thanks for joining in,
Thank you very
folks.
much.
And yeah.
Bye-bye. And we wrap our stream up. Let me remind you folks again about some links we have. Please follow us on Twitter to stay updated about the next events, and I'll be super happy to see you as a speaker on this virtual stage, or maybe starting from like late autumn, if possible, again to gather in person. So yeah, we'll see. Let's hope for this. On that. I wish to say thank you for watching us. Maxim Salnikov was with you as today's event host. Have a perfect evening, and bye-bye.